right, ladies and gentlemen, we're starting with chapter 3-4, notes, day 1. We're building quadratic models, and we're going to do that with verbal descriptors or descriptions, and then from data. And we'll do the data one tomorrow. So this one is just all basically word problems. So some of it's pretty easy to set up, so let's get started as we're doing that. So building a quadratic model from verbal descriptions. In economics, revenue R in dollars is defined as the amount of money received from the sale of an item and is equal to the unit selling price P in dollars of an item times the number of X items sold. So revenue is X times P. Again, X is the number of units and then P is the price, okay? The unit selling price. So if I want to know what my revenue is, I've got an iPhone that's $600 and I sell 3 of them. Then I take 3 is X. I have 3 iPhones, $600. 3 times 600, I got $1,800 in revenue. Okay, pretty easy stuff. Well, it says the law of demand states that P and X are related. Okay, you guys know law of demand. Okay. Supply, demand, you got to get that perfect spot where you have the right amount of items and you got the right price, okay? And that will create the correct demand for it. As one increases, the other one decreases. The equation that relates P and X are called demand equation. When the demand equation is linear, the revenue model is a quadratic function, okay? So revenue equals X times P. Let's get started as we're going through. They want us to maximize our revenue here. Look at this. I got some TI-84s. Okay, the marketing department at Texas Instrument has found that when certain calculators are sold at a price P dollars per unit, the number X of calculators sold is given by this demand equation. X equals 21,000 minus 150P. Okay, so it says find a model for part A. It says find a model that expresses the revenue R as a function of the price P. Okay, so what does that mean? Okay, we have R in terms of P, right? Well, the equation we know for R is R equals XP. Okay, that was found up here, this guy right here. All right, we're going to take this equation now. We want this R in terms of P. That means get rid of this X. Well, we already know X is equal to this. So I want to, in terms of P, I want to get the X out of there. Okay. So I plug that in. So now I've got R equals X, which is now 21,000 minus that 150P. And now times this P. Okay. So again, we want a model that expresses R as a function of P. We want this R in terms of only P. So I distribute. And now you can see I've got my function R of P. That's like f of X. It's just function notation. And that equals, and I'm going to write it negative 150 P squared. So I'm going to do this one first. And then multiply here. I've got plus 21,000 P. Okay. So this is part A. This is in function notation. If you just have R equals, that's fine. I have R of P equals just so that it's written in function notation. Okay. Now do you guys see why we have a quadratic? We have an X squared term, or in this case, P squared. So we know we're going to have a graph. Do we have any ideas if this is going to be a smiley face or a frowny face? What do you guys think? And how do you know? Smiley face or frowny face?
Would it be a frowny face?
Why? I agree.
Negative 150p.
Yeah, so this is your A value. We talked about before, if A is negative, we're going to have a frowny face. Okay, perfect. So we're going to graph this thing. I don't know what it's going to look like. I just know it's going to be a frowny face like this. Okay. and it says, what is the domain of R? All right. So we got to find that. And it says, what unit price should be used to maximize the revenue? So what I want to do is I want to get a visual of what this thing looks like. Okay, so this is where I grab my TI 83 or 84. So if you need to, go grab it. Okay, hopefully it's charged up, ready to go. So let's take a visual of this thing. Okay, this is all calculator work here. Let's see if I can adjust. All right, so that you guys can see that. All right, this is what I'm gonna do. I'm gonna type in the function in my calc. I'm gonna type in negative 150 x squared. I've got plus 21,000. Make sure you have 3 zeros there, and then x. Make sure you have the x. Okay. I also want y2 to be 0. Okay. Again, that's going to be my x-axis. We're going to probably need that, so let's go ahead and graph that. So I have negative 150 x squared plus 21,000. Make sure you have the right amount of zeros. There's 3 zeros there. And don't forget the x at the bottom or at the end. And then I have y2 is 0. Okay. I always start in zoom 6, and I know I'm not going to see what I want. Okay, I don't see a frowny face. So the next thing I always try is zoom 0. So I go zoom. You can toggle down to 0. I just press 0, but I'm just going down there so you can see it. We're doing zoom fit. Okay, so visually what's going on is I don't see what I want to see, okay? The idea is I'm zoomed in too much of this parabola. I can see that it's kind of curved, okay? But I know, I think it was maybe Adam or Tyler said, hey, we got a frowny face. Uh-oh, somebody's having some calculator problems. If you're getting a dim mismatch, go up to your plots and make sure your plots are off. So if your plots are on, go to y equals and turn them off and see if that works. And just use your microphone. Let me know if it works, or anybody else having issues? Anybody else not getting this graph? I'm in zoom 0.
How do I turn the plots off?
Go to y equals. So if you're getting a dim mismatch error, you probably have your plots highlighted up here.
Yeah.
And then go up there and turn them off. Go press enter. Turns them off.
Okay, thank you.
Yep. Anybody else not getting this graph? So I've done zoom 6, I've done zoom 0, and I still don't see my parabola the way I want to see it. So then I'm going to go zoom 3, zoom out, okay? And then you're going to get to this screen, just press enter one more time, and it will zoom out. And now I can start seeing that parabola that I want to see, okay? Still don't see what I want. So I'm going to press enter again. And that, look at that. Perfect.
Mine's just a straight line.
Yours is a straight line.
Yeah.
Okay. Did you use zoom out?
Yeah.
Okay. So let's go to your equation. Do you have the x squared?
Yeah.
So you should have negative 50 x squared plus 21,000 x.
Yeah.
You have that? Yeah. So start in zoom 6. So I'll walk you through it again. Zoom 6.
I made a straight line on the y-axis.
So do you have that on zoom 6? Okay. So you have a straight line. Then we did zoom 0. Zoom 0, that's zoom fit. You should see this. Do you see that?
Yeah, okay, I think it's working now.
Okay, now we do zoom 3. And we press enter. And you just got to do it one more time.
22.
Got it?
Yeah.
Gotched it. Okay, domain. Now, the only thing I care about for this graph, I don't care where in this, in this case, where the revenue is negative. I don't want negative revenue. I only want it above 0. Okay, so when it says what's the domain, I only care about this part, this little hump. Okay, so that's the only one I care about. So this is when your price, your revenue is 0, and the amount of, your price is 0 for X. So that's going to be 0, 0 right there. So I'm going to make that 0, 0. And you can find that if you want the intersection. I guarantee it's 0, 0. But we also want to find this intersection, this guy right there. Okay, and again, that's for our domain. So I'm going to go second trace intersect. And you have to have y2 is 0. If you don't have y2 is 0, you got to go back into y equals and do that. Okay, so second trace intersect, first curve enter, second curve enter. Now if I press guess here, it's going to find 0, 0. I already know that's 0, 0, so I don't need that. I'm going to go move over here and press enter. And now I have that intersection. I have 140 for X, which is really our P, our price. And our revenue would be 0. Okay, so this guy's 140. All right, anybody not getting that?
Yeah. What did you do when you pressed the first enter and the second, or this first curve and second?
Just press enter. Second trace intersect. First curve, they're saying, hey, what curve, what graph do you want to intersect? We only have 2, so we just press enter on the first one, enter on the second one. And then guess is where you move it. I wanted to find the far right one. I press enter, and it jumps to the nearest intersection. So first curve enter, second curve enter, guess enter. You guys are asking great questions here. All right, so again, we want our domain. The only part of the graph we care about is from here to there. Okay, so one way you could write for domain, low number, high number is 140, X in the middle, in this case, P, and then less than signs, and equal to. Okay, or I prefer interval notation. I prefer bracket 0 to 140 bracket. Okay, so either one of those. I like this one better. You just got to see what my math lab wants. Okay, so the only thing they care about is this hump. We don't care where our revenue is negative. We don't want negative revenue. That would be crazy. We at least want to know our break-even point for revenue. Okay, so far so good? All right, so I take a look at the next one. It says if, it says what unit price should be used to maximize the graph, this revenue. Well, we know what that is, right? We want to find the top of the mountain right there. Now we could use our axis symmetry. We could use x equals negative b over 2a, but we already got this thing graphed. Let's go ahead and find the top of the mountain right there. All right, let's find that point. So I go second trace, and which one do I want? Trying to find the top of the mountain. Maximum. I go down to number 4. Okay, we agree this is the left, and we agree that's the right of that point. So when it says left bound, I want to get to the left of that maximum point where it's increasing from left to right. Press enter. Right bound. Get to the right. Guess. And there we go. You might be getting 69.99999, round up to 70. Okay, so this one right here, I have 70, comma, 735,000. Okay, so that's my point. When's the price? Which one's the price? Well, up here in my equation, X is my price, R is my revenue for Y. So that's P and that's R. Okay. So in this case, my price should be charging $70. Wouldn't it be nice if your TI-84 was $70? Says if the price is charged, what's your maximum revenue? So your revenue max from up here we had was 700 or 735,000. Guys good with that? So far, so good. Any questions? Peyton Lucas, can you get out of the kitchen? Come on, I hear you. I'm getting feedback. People are saying, who are these kids talking? All right, do you guys have any questions? All right, let's move on to the next one, part E. So part E says how many units are to be sold, okay? So we have a formula for units, don't we? What represents the number of calculators up in the up on the top here? What's the number of calculators? What variable are we using? Yeah, we're using X, right? Number of calculators. All right, so how many units, how many calculators are to be sold at that price? This is where we use a couple different ideas. You can do X equals that 21,000 minus 150p. Okay, so I would get X equals that 21,000 minus 150 times that 70. You just throw that in your calc. Okay, I'll throw that in the calculator here. So 21,000 minus 150 times 70. And I'm selling 10,500 calculators. See where you can see this here. All right. All right, any questions with that one? Now, other than you could do, we know R equals X times P. You could also do this. You could divide the P over and get R over P. Okay. So we could do that as well. So if I take that revenue, which was 735,000, I could divide by the 70 and get the same thing. So you got two ways to do it. So if you want to do it that way, and again, remember, you guys have notes, right? You have your notes on the quizzes and tests. So I would have that somewhere also. All right, last but not least, any questions? Any questions on how I'm getting that 10,000? We got one more thing we do on this question. It's a good question. Real life stuff here. Says here, what price should Texas Instrument charge to collect at least $675,000 in revenue? Okay. Now revenue, that's R, right? For our equation, is that X or Y? We're talking about revenue. Look up here. Is that X or Y for R?
Y.
That's Y. So in our graph, if we can graph Y is 675,000, then we should have a idea of what price to charge. Okay. So they're saying, hey, why is this? Find our X value, question mark. Again, price is our X. So how do we do that? We have the graph already. Now we just want to go to Y2 and graph the Y value of 6 675,000. Okay, so 675,000 for Y2. What that is going to do is give us that nice, pretty horizontal line. So I'm going to go ahead and graph that. I'm going to give myself a little visual on my graph. Again, we're looking at this part here. There's my graph. And then we're going to graph again. Y2 is just this horizontal line right here. Okay. And what I want to do is I want to find out what this is and what this is. I want, again, what price should Texas Instruments charge to collect at least? Okay. So at least is right here. I want to find that value. This guy right here, there's two intersections I want to find. I want to find this point and I want to find this point. Okay. All right, let's find that. Second trace, intersect. First curve enter, second curve enter, guess. Jumps to the intersection. So this point right here is at 50. So I have 50, comma, 675,000. 675,000. Let me know if you're not getting that. A lot of calculator stuff today. Second trace, intersect. First curve enter, second curve enter, guess. I want to move my cursor over to the right. I want to find that intersection. Press enter. And now that's 90. Okay. So now this one is 90, comma, 675,000. So the price that I need to charge these people, all right, us consumers, is somewhere between 50 and 90. Okay. And that way they're guaranteed to get 675,000 or more, right? They don't want to charge less than that because their money will be less. This is their revenue. We don't want to be below this red line. Okay. All right. So final answer, low number, high number for the X's. X in the middle, in this case, price in the middle. Less than or equal to signs. It's kind of like the domain. Okay. And we're talking about money here. Now I prefer to write this as a interval notation like that, where I'm talking 50 bucks to 90 bucks. All right, ladies and gentlemen, any questions on that one? That had a lot. I get it. It's a lot to remember, okay? When you're walking through your My Math Lab stuff, go through it, all right? Step by step. I've walked you through all the steps. Hopefully we took good notes today, okay? If you skip the My Math Lab stuff, well, good luck on trying to do this on a test, right? There's just too much to know. So you got to practice this stuff. You guys have any questions? Again, talk about real life stuff. Here we go, guys. All right. I'm moving on to the last one. Ding, 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 ding. Maybe you're going to be a farmer. We got farmer Emily P. Who knows? She wants to enclose a rectangular field, and Emily has 3,000 feet of fencing available to enclose a rectangular field. So here we go. It says express the area A of a rectangle as a function of x, where x is the length of the rectangle. Okay. All right, well, let's talk about this rectangle here. I don't know what the sides are. They're saying, hey, let's have it as x. So I'm going to put an x in here. And I don't know this length, so I'm going to call it y. So this is y, and this is x. Okay. Well, they asked us to express area, right? Well, right now, what do you guys know of the area of this rectangle from Geom? What do you guys know about area, y'all? Area.
Length times width.
Perfect. Length times width. In this case, I've got x times y. Okay. Well, they want us to express this in terms of x. Right now, this is in terms of x and y. Okay. So this is where we go back to the idea from the first part is we need another equation. Okay. In example 1, they gave us that equation. All right. Well, now in example 2, we got to come up with that equation from the information that they gave us. They talked about they have 3,000 feet of fencing available to enclose this. Okay, well, when we're talking about enclosing an object, in this case, we're talking about perimeter. Okay, so perimeter of this guy is adding up your x's and your y's. I've got 2 x's and I got 2 y's. You guys agree with perimeter? Okay. Well, we know what P is. We know P is 3,000. I know that's how much fencing I have. So really the equation I have now is 3,000 equals 2x plus 2y. Okay. We want to get this in terms of just x. We want this guy out of here. So what we need to do is we need to get y equals something so that we can plug it in. So we're going to use this equation and we're going to solve for y. Okay. So I'm going to go ahead and subtract that 2x over. So I have negative 2x plus 300,000, or assuming 3,000 equals 2y. And I'm going to divide everything by 2. You guys okay with this? So I end up with negative x, and this is what, 1,500? Or 1,500 minus x, whatever you want. Doesn't matter. Okay. Questions so far? I'm going to take this. I want this in terms of just x. I'm going to plug it in, plug it in. So now I've got area equals x, and then times this y, which is negative x plus 1,500. Remember, this is all about quadratics, so we should get an x squared, and we do. We get a negative x squared plus 1,500 x. Okay. Now, if they want it in terms of function notation, instead of f of x, it would be a of x. So area in terms of x. Okay. So part A is done. I've expressed that area is just x, where x is the length of the rectangle. Okay. Part B, for what value of x is the area the largest? Okay. Well, we know what this is a graph of, right? We know this is a frowny face. I think it was Tyler that said, hey, that if that a value is negative, we got a frowny face. So when I graph this thing, it's going to look like that. And we want to find the largest. What's another word for largest, y'all? Largest. What's largest, y'all?
Maximum value.
Max. The maximum. We want to find this guy right here. Okay. You could use axis symmetry, x equals negative b over 2a, or we can use our calculator. So I'm going to go ahead and do that. I'm going to clear out all this other stuff we had graphed. Just press clear. And I'm going to type in this function right here. Okay, I'm going to type in negative x squared and then plus 1,500x. Okay, you could graph y to a 0. We don't need it. We're just finding a max here. That's it. So I've got negative x squared plus 1,500x. I always start in zoom 6. Zoom standard. I know I'm not going to see what I want. Sometimes I do, but these are big numbers, right? My window's way too small. So I can try zoom out. I like to do zoom 0. I do zoom 0 first. So I did zoom 6, zoom 0, and now, you know, the idea is it's like I don't see what I want. I see like this almost like a line. That means it's zoomed in too much. Okay, so then that's when I do zoom 3. And press enter. Okay, so I'll write my zooms, my zooms. I always like zoom 6, then I try zoom 0, and if that doesn't work, then I do zoom 3, and then I just keep pressing enter until I find what I want. Okay, the other option is I could just mess around with the window. I just don't like doing that. I'd rather do it this way, and then I don't have to think about what numbers I need. So I zoom 3 and press enter a bunch of times, probably 4 times. Okay, let me know if you're not getting this graph. Any issues, y'all? All right, I want to find the top of this mountain right there. Left bound, right bound guess. Second trace, maximum. Left bound, press enter. Right bound, press enter. Guess, press enter, jumps to the top of the mountain. I got 749.9999999. You might have got 750.000000. Again, round that. Okay, usually it's a nice number. So we got, again, 750, comma, and then if you can see, I got 562,500, 562,500 for y'all. Okay, so what value of X is the area the largest? Again, that's where I got 750 feet. Okay, what's the maximum value? What's the Y value? So my max area was 562,500, and area is in feet squared here. Okay. All right, ladies and gentlemen, I am officially done.